Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be exploring about 2D arrays. So let's start. In our previous lecture, we have explored about 1D arrays. We have seen how we can create a 1D array using Python list and how we can do some basic operations and how we can access items in an 1D array. And we also have learned that 1D array in Python is dynamic in nature, means size is not fixed, and in each element we can store any data type. We can store string, we can store any data type like list. Now let's assume, so this is a 1D array, right? Now in spite of storing a numeric value, let's say I want to store an entire list here. Let's say, so I want to store 1 2 3 this list inside this, and similarly 4 5 6 this entire list in this element, and also this 7 8 9 inside this element. Now tell me, is it possible? It is possible, right? Because Python lists are very flexible. Now you can see this list has become the 2D array because this is an array of arrays. These are arrays, and this entire thing is also an array. So this array of arrays is basically called 2D array, right? Now, so this is an 1D array, and each value inside this 1D array are called elements. And how we can access these elements? We can just write array, then in the square braces we have to give the index of it. And how we can iterate over this? We use for loop to iterate over this. We can write for element in array print element, or we can use the index concept. So first we have to create a range from 0 to length of the array, then we can print the items one by one, right? But in 2D arrays, if we try to access, let's say this is a 2D array, this is a 2D array, and if we want to access, let's say mat of 0, then mat of, let's say 1. Now what it will return? If we try to access mat of 0, it will return us this entire list. And if we try to access mat of 1, this will also return us this entire list. These are basically called rows in 2D array, right? So this is called rows, and when we try to access elements inside these rows, these are called columns. Means for a row, so if we try to access this element, this is called column 0, then this is called column 1, then this is called column 2. Okay, so you can think like matrix. Okay, so matrix has rows, so these are rows, and these are basically columns. These are rows, these are rows, and these are columns. Okay, now if we try to access a element in an 1D array, what we have to write? We have to write just array and then just index, right? But in 2D arrays, we need two indexes. One is called row index, one is called column index. Means, let's say I want to access this element 4. Now how can I access this? To access this, first I have to go to row number 1, because all row and column index always start from 0. So rows index will be first will be 0, then it will be 1, then it will be 2. Similar for column, it will be start from 0 1 and 2. Now if I want to access this 4, first we have to go to this row 1. So it will be like mat of 1, then the column index. What will be the column index of this 4? This is 0. So we can access like this. First will be row index, this will be column index. Now we can see the column index start from 0 to length minus 1, and row also same, row index will be start from 0 to length minus 1. So then what will be the index for first element in this matrix? It will be nothing but row 0 column 0. Then what will be the second thing? It will be row 0 column 1. Similarly row 0 column 2. Same in row 1, it will be like for 4 it will be like 1 0, then 1 1, then 1 2. Similarly, for 7, it will be 2 0, 2 1, 2 2. So that's how we can access elements using row index and column index. Now, let's say I want to access this 8. How we can write? We have to write first the name, that will be matrix. Then, what will be the row value? It will be 2. Then, what will be the column index? It will be 1, right? Now, if we write mat of 2 and 1, it will return us 8. First, let's say I want to iterate over a row. Let's take row 0. So if I print mat of 0, this will return me a entire list containing 1, 2, and 3. Means this entire 1D array. So this is an entire 1D array, right? So now, can I iterate over this 1D array? Yes, I can, right? To iterate, I need a for loop. I need a for loop. So let's assume this entire thing as array. Okay. Now how I can iterate over this? So I can write for j in range. And what will be the range? The range will be from 0 to the length of the array, right? Here you can assume this array as mat of 0. Okay. That's what I have written here. So you can see this mat of 0. I'm running a for loop and I'm taking an index j in range from 0 to length of this first row. And what I am printing? I am printing ARR of j. That means mat of I, then j. Now this I value is 0. Initially it is 0. That's why I'm printing 0 and j. So this is for row 0. Now similarly, if I want to access all the elements in row number 1, then what I gonna do? Same thing. The I will be replaced by 1. And similarly for row 2, so I will be replaced by 2. And the remaining code will be same. So now we have understood how we can access elements inside each row. Now, to print the whole matrix, the whole 2D array, what we have to do? So this for loop will remain same, but for this I we have to take another for loop, because this I also starting from 0 and going till I equals to 2, right? So that is the case. That's how we can print the 2D array. So we'll be running a for loop. For will be starting from I to length of this matrix. So length of this matrix will be nothing but the number of rows. So here, if we try to print length of the matrix, that will return us 3 number of rows. So that's why we are taking one for loop. Then inside this for loop, there is another nested for loop. So first we are taking index I, that is range from 0 to length of the matrix. Then we are taking another index j, that will range from that each row, right? From 0 to that column. How many columns we are trying to print, right? So let's go to our VS Code and let's try to create a 2D array. Let's say matrix mat equals to, let's first element as 1 2 3, then second row as, let's say 4 5 6. Okay. And third row like 7 8 and 9. Now how to print this? So we're gonna run a follow for I in range. Range will be from 0 to length of this mat, right? Then we'll run another for loop for j in range, and j will range from 0 to the length of this mat of I. Okay. And then we're gonna print this mat of I, then j. And at the end we can print like end equals to, then some space. And after that So we're gonna write a space. So that is, this ending is because of I want to print this whole items, whole elements in a single row. Now let's try to execute this. Now you can see this is printing this 2D array. So that's how we can iterate over this 2D array. Also, there is another way how we can print the elements in this matrix or 2D array. So what is this process? That is basically, first we'll be iterating over the row. So each row in this matrix, then we'll take column in each row, then we'll print this column. Let's say how we can do this. Let's comment it out. So let's run a for loop for uh, let's name it as row in matrix mat. So when I run this, so this row will be nothing but this elements, this rows. So this will be 0, this will be at this. So it will be iterating over this. Now when we try to write call in row, means we want to access every elements inside this row. And if we print this call and try to run this, so okay, I have to give the int to 0, and after each column, after each row, I want to give a space. Even next line, and let's try to run this. Now you can see this is also doing the same thing. So that we are printing using indexes, row index and column index, and that we are printing using iterative approach. So I hope now you have understood how we can iterate over the 2D array and print all the elements in the array. Now let's look at our first problem in 2D arrays. So what is the problem? The problem is telling us about to find the sum of diagonals of a matrix. When we talk about diagonal of a matrix, so there are two things. One is principal diagonal, one is secondary diagonal. What are the elements in the principal diagonal? So these are 1, 5 and 9. These elements falls under principal diagonal. And what the elements are fall in this secondary diagonal? 3, 5 and 7. Now we have to calculate the sum of principal diagonal. So that will be nothing but 1 plus 5 plus 9 equals to 15. And we have to find the sum of secondary diagonal. That will be 7 plus 5 plus 3. Now let's see how we can solve this problem. So there will be two sum. Like for principal diagonal, one sum. Then for secondary diagonal, there will be another sum. So let's assume this is the matrix, and the elements in the principal diagonal will be this, right? So this is basically principal diagonal, and the elements fall inside this are 1, 5 and 9. Now how we can calculate the sum of these three elements? If you observe this carefully, you can see a pattern. You can see a one thing is common in three elements, and this common thing is in this indexes, this row index and column indexes. So if you take a look, so what is the index of this first element? It is 0 0. Then for 5 it is 1 1. Then for 9 it is 2 2. Means the row index and column index are same in this three elements. Now if we want to calculate the sum of principal elements, first we have to iterate over this 2D array. We have to go through each row, and we have to check. You have to check if the index, row index and column index are same. Then only we can add this inside principal sum. So let's try to solve this. So let's remove this, and let's take this matrix, and let's create a function called def find diagonal sum. It will take a matrix, then let's say n equals to 3. That is basically, so this is basically 3 cross 3 matrix, and we want to pause this. Okay, n. Okay, then what we have to do? To calculate the sum of the principal diagonal. Now how to do that? So first let's take a variable, let's say pd sum. So this is basically short term of principal diagonal sum. Let's initialize to with 0. Then we'll iterate over this matrix. Let's say for I in range will be from 0 to n, right? From 0 to n, because this is n cross n matrix. So row is also 3 and column is also 3. So we can in short we can take this and then we'll run another for loop for j in range, that will also. So this is for each column and it will from 0 to n. Then we'll check, what we'll check, if I equals to j. So row index and column index, if those are equal, then we can increment this pd sum by whatever this element mat of I and j, right? So this is basically principal sum. Now what is secondary diagonal sum? So what is the secondary diagonal here? So it will be nothing but this. Now observe these elements carefully. This is 7, 5 and 3, right? And now if you look at the row index and column index, so it is 2 and 0, then for 5 it is 1 and 1, then for 3 it is 0 and 2. Do you see any pattern here? Look, when you add this 2 and this 0, means the I and j, so it will become 2. Then for this 1 plus 1 it will be 2. Then for 0 and 2 it will be 2. So this is the pattern, right? So when we try to find out the secondary diagonal, so that pattern will be nothing but I plus j value equals to, what will be the value? I plus j value equals to n minus 1. So here n is 3, because this is 3 cos 3 matrix. This is 3 cos 3 matrix. And here the condition will be like I plus j equals to n minus 1, means 3 minus 1. Here n is equal to 3, then 3 minus 1 equals to 2, right? So this is the condition. Or we can say like I plus j equals to 2, or we can say I equals to n minus 1 minus j. That also we can say. That is the same thing. I plus j equals to n minus 1 or I equals to n minus 1 minus j. So let's see how we can do that. Now we'll take another variable, let's say secondary sum, and also initialize with 0. Now inside this iteration we'll again check if I equals to, what is the condition? N minus 1 minus j. If I equals to n minus 1 minus j, then we can add this element inside sd sum. Sd sum equals to mat of I then j. And at last we'll be printing this. Print, let's say principal diagonal sum, let's put equals to, then pd sum, then similarly secondary diagonal sum equals to sd sum, right? And let's try to execute. Let's clear this out and let's try to run this. Okay, we have to call this, let's call find diagonal sum. Then inside this we have to put the matrix mate, then n. And now if we try to run this, now you can see the principal diagonal sum equals to 15 and secondary diagonal sum equals to 15, and this is the correct answer. Now what is the time complexity for this algorithm? you can clearly say, so here is one for loop is running for row, and then another for loop is running for iterate over the each element in this row. So that's why we are considering this two for loop, nested for loops. So the time complexity for this algorithm will be nothing but n square, and that we have discussed previously, how if there are two for loop, nested for loop, how the time complexity become big of n square. So that's why here the time complexity is big of n square. Now tell me how we can decrease the time complexity, or how we can think about optimal solution. Can we solve this in big of n? Let's see how we can do that. So currently in our problem, we are iterating over the whole matrix. Like we are going like this, then this, and we are checking for each element, right? We are checking for each element. But what else we can do? We know the condition. What is the condition? For principal diagonal, the condition is I equals to j. And for secondary diagonal, what is the condition? The condition is I equals to n minus 1 minus j. Right? This is clear. This is the condition. Now tell me what are the elements in the principal diagonal? Those are nothing but 0 0, then 1 1, then 2 2, right? 2 2. Now in spite of iterating over the whole matrix, if I run one for loop, and I will be running from 0 to 2, then I only just add this mat of 0 0, then mat of 1 1, and then matrix of 2 2. So I'll add this up. Will that give me the correct answer? Yes, it will. Definitely it will. So for this, we are just going through only 3 times, not the whole iteration. Now, similarly, for secondary diagonal, so what we have to do? We have to run a for loop for I that will range from 0, 1, 2. Then what we'll do? We'll add mat, and it will be 0. Then j will be n minus 1 minus j, right? So n minus 1 minus, so this j, sorry, this will be I, because I and j are equal. We are taking just one index. Then it will be mat of 0, then n minus 1 minus 1, sorry, it will be 1, then mat of 2, it will be n minus 1 minus 2. Let's see what we are doing. First we are taking mat of 0, so 0, then n minus 1 minus 0 means 2. 2 minus 0 equals to 2 means we are considering this element. Then mat of 1, so this is 1. Then n minus 1, this is basically 2 minus 1 means 1, 1 1. Then mat of 2 means 2. Then n minus 1 minus 2 means 2 minus 2 equals to 0 means this 7, right? So that's how we can optimize this problem. Let's see how we can do that. So in spite of doing that, let's copy this out and comment the first solution. Let's comment it out. Now let's take two variable and remove this one. Now let's run a for loop for I in range, and range will be from 0 to n because I and j are equal, row and columns are equal. Now pd sum plus equals to, if we write mat of I, and this will be also I, because 0 0 1 1 2 2 means the column index and row index will be same. And for sd sum, secondary diagonal sum, what are you gonna do? No, right, mat of I, then what will be the value of j? It will be n minus 1 minus j, right? Now let's clear this out and let's try to run this. Now you can see this is also giving us the correct answer. And what will be the complexity of this algorithm? This is only running one for loop, right? Using one for loop, we can, okay, I have, okay, now let's try to run this. Yes, this is giving 15. So what will be the time complexity for this algorithm? Okay, okay, okay. Okay, I have to remove this out. Sorry, it's my mistake. Now let's clear this out again. And if we try to run this, now this is giving 15 and 15. Now what will be the time complexity for this algorithm? It will be nothing but big of 1, big of n, because we are only just running one for loop. And this for loop is running for 0 to n minus 1. That's why the time complexity is big of n. So this is having time complexity big of n square because we are running two for loop here. But here we are running one for loop. That's why the time complexity for this approach is big of n. So that's how we can find optimal solution. So I hope now you have understood how we can solve 2D array problems. So thank you. That's it for today's video. See you in the next lecture.